Hi, my name is Adina Turlakovic. I'm a senior research scientist at EPS Literacy and Intervention and also one of the principal investigators of the Pad Driver for Math research project. This presentation is an overview of the Pad Driver for Math research project. Our goal at EPS is to provide their customers with research-based products. Pad Driver for Math has a strong research foundation and it is a true research-based product. First, I will explain that statement. The second item that I will address in this presentation is the North American research study in which data for establishment of national norms for this assessment product was collected, and the last item addressed will be an explanation of the process of calculation of national norms. The goal of the Pad Driver for Math research project was to develop an online research-based mathematics assessment intended for general benchmarking, often referred to as universal screening, and ongoing frequent assessment throughout the school year, referred to as progress monitoring. The target student population were students in kindergarten to grade 10. In other words, we wanted to be able to offer to our customers a product that is computer-based with automated scoring, research-based, and efficient and easy to use in the RTI environment. There are different types of research that need to be considered for educational software development. These are innovative research, research related to product implementation, and efficacy research. Pad Driver for Math went through all of these stages. During each stage, the product was very carefully reviewed and the necessary research was conducted. For instance, during the innovation stage, the most recent mathematical cognition theories were reviewed and tasks suggested to be the most reliable predictors of math proficiency were implemented. During this phase, we also looked into translating these tasks onto the computer screen by considering research related to software design and computer-assisted instruction and assessment. As for the content of the product, in addition to mathematical cognition theories, state and local standards for classroom curricula were considered. During the development phase, we tested the graphical user interface several times at various schools with kids of different grade levels and made changes accordingly. The last research phase, the efficacy phase, included a 2-year North American study with over 12,000 students from 10 different states and 1 Canadian province. As pointed out on the previous slide, the task design of Pad Driver for Math was based on the most recent mathematical cognition theories that address predictors of mathematical proficiency. Researchers have identified 3 specific tasks as being reliable and valid predictors of math proficiency, those being computation, magnitude comparison, and number line estimation. First, the computation task requires students to apply the 4 basic arithmetic operations to whole numbers, fractions, and decimals. Second, in the magnitude comparison task, students must indicate which of 2 sets is the more numerous. Finally, for the number line estimation task, students translate a written number to its placement on a number line. These 3 specific tasks were implemented in the Pad Driver for Math design, in which each predictor comprises a separate subtest or probe. Test content was determined in a large level appropriate synthesis of materials from state and local standards, published classroom curricula, national professional organization, and national reports such as National Mathematics Advisory Council. Each subtest or probe of PAD Driver for Math is designed to assess students of widely varying abilities across a multi-grade sequence of development, a research-validated procedure similar to stratified sampling. This means that the probes include problem types that are familiar even to lower achieving students, as well as problem types that have not yet been taught as part of typical classroom curriculum at early grades in the sequence. Each probe has a large pool of questions with up to 6 levels of difficulty, so the different mathematical concept can be treated differently based on the grade and expected skill level of students. Probes are 1 to 4 minutes long and are preceded with a tutorial session that helps students understand the task requirements. Each student logs in with a unique username and password. In each probe, questions are algorithmically generated by question type. Furthermore, item presentation order is randomized and tracked to ensure equivalence of test forms from one test administration to the next. The presentation order is randomized according to the levels of difficulty. Let me now tell you about the efficacy research for this product. In August of 2010, we started a 2-year North American study in collaboration with Dr. Ernest Belady from State University of New York at Geneseo. Our goal was to determine normative data for PAD Driver for Math. There were 2 goals to this study. One was to determine national norms or grade level benchmarks for the universal screening component of PAD Driver for Math, and the second goal was to determine bi-weekly points of reference or grade level benchmarks for the progress monitoring component of PAD Driver for Math. We tested general student population of approximately 12,300 students. Grades included in the study were from kindergarten to grade 12. In this study, we had 29 participating schools from across the United States and 1 Canadian province. The states included in the study were Montana, Alabama, Texas, Illinois, Indiana, Louisiana, New York, Kansas, Ohio, Texas, and British Columbia. Final sample of students for the study were chosen from the overall populations of students tested, and the final sample roughly matches the national student population. Each school that participated in the study was required to test their general student population, meaning all of their students from each grade level, 3 times during a school year, during each screening period with PAD Driver for Math. The schools were also given an option to progress monitor their non-proficient students bi-weekly or once a month. Every time they completed testing, we provided them with a detailed report. The main measure used in the study was PAD Driver for Math. In addition, we used student data from various state and standardized tests adopted at participating schools. In math curriculum-based measures, RAS scores are problematic because they fail to account for differences in item difficulties that typically arise from alternate test forms. For that reason, in PAD Driver for Math, we employ a complex, weighted measure that takes into account the varying difficulties of items in determining universal screening and progress monitoring scores. A student's total score is determined by analysis that transform the RAS scores from different probes into a common score. The calculations involved in developing this metric were researched in the norming process, Students' performance on the probes of Pad Driver for Math were carefully examined and compared to their performance on various standardized and state tests. This presentation was an overview of the research basis for the design and development of Pad Driver for Math, the North American research study that was used to establish national norms was described, as well as the process used to calculate the national norms. If you have any further questions, please feel free to contact me. My email address is adina.terlakovic@schoolspecialty.com. Thank you for taking the time to learn about the research basis for Pad Driver for Math. If you would like to learn more about the program, please visit our website at epsbooks.com/PVM.